Now we come to this term, multiplicity. Multiplicity just means a repeated zero. So repeated zero is the same thing as multiplicity. So if you had a factor, let's just say it's x minus 2 to the power of 3, what you would say is that the 0 does occur when x equals 2, but it has multiplicity of 3. That just means it occurs 3 times. That's all that means. This is an example here, so you're not confused. So let's look at this. So given this equation, we could do quite a few things here. First, I want to show you how you would add up powers. This has, since these are multiplying, it's almost like you have 1, 2, and this is 2 powers of x, so you have 4 powers of x. When you multiply x times 3x, I'm only going to take the x values times, over here we have x squared. It's kind of like you have 3x to the 4th power. And I kept the coefficients in front because if it's a negative, it changes it. That means my graph's going to look like a parabola. I'll have a facing upward with, at most, 4 zeros and 3 turns. Oops, that's not how you spell turns. There it is. 3 turns. We could also write our limits from this. So I'm just tying together the whole lesson. We could say that what happens to the equation, what happens to y as x goes to the left? Well, the graph goes up. And what does happen to y as x approaches the right is it also goes up. We could write all that out. And we could also state what the zeros are. Here, we could say that this one, x equals 0, and we'll hit, that'll be a 0 here. We could say that x equals -1 divided by 3 because I'm solving for x. There, I would say that x equals 2 with multiplicity of 2 because it occurs twice. All right. Now here, oh, it's the same thing. I just tied it all together. So we just determined the zeros and any multiplicity. I just did that. We had x equals 0, x equals -1/3, and I had that x equals 2 with multiplicity 2. And so if I had to graph this, what I could do right away is I know those points, and I know how it's going to face. So we said we know it's going to hit right there at 0. We also know it's going to hit at -1/3, which I'll just do like really close, and then at 2. So if that's -1/3, 1 unit would be about that far away. And so this would also hit on that spot there. I'm going to change my color so it's easier to see. So here's what I know. It's going to come up like that, and it's also going to hit there. Since this is multiplicity 2, it'll turn on that point. I also know this is going to form like it's going to go up this way. So if it turns on this point, I got to make a parabola here. And so I'm just going to assume it's something like that. And then it would come down and back up this way. That would be a rough sketch that you could have just by graphing like that. Now, if you wanted to find, let's say, how far this goes up, you would just plug 1 into the equation. So if I wanted to do, I could say that f of 1 could equal, you plug it in, 1 times 3 times 1 plus 1 times 1 minus 2 quantity squared. All right, let's go in order. I need to do the squaring first. So 1 minus 2 is -1. You square it, that's +1. So I have +1 there, times over here I have 3 plus 1, which is 4. And here I have 1. So I have 1 times 4 times 1, which equals 4. So when x is 1, y equals 4. That means this point needs to be up 1, 2, 3, and 4 units there. That would be the point 1, 4. So that's how you do that if you wanted it exact. All right. So now let's look at the actual picture, and we'll see how close we came. Right there, it's at 4. We had the turn at 2. We also hit at 0 and at 1. So we came pretty close there on our graph. Now you try and see what you can come up with for this example 6.